Class 1 Division 2, or C1D2, refers to a hazardous location as defined by the National Electrical Code, NEC. These are areas where ignitable concentrations of flammable gases, vapors, or liquids are present but are not likely to exist under normal operating conditions. The selection and installation of electrical equipment in C1D2 locations must adhere to specific standards to minimize the risk of ignition. When considering multi-conductor cables with screw-type quick connects for C1D2 applications, the primary concern is to ensure that the connection remains secure and gas-tight, preventing the potential for sparking or arcing that could ignite the hazardous atmosphere. The need for an additional locking or set screw is a point of contention that arises from varying interpretations and applications of the NEC and related standards, such as those from UL, Underwriters Laboratories, or ISA, International Society of Automation. Let's break down the factors that influence this requirement. Firstly, the NEC itself provides guidelines for equipment suitable for C1D2 locations. Article 500.8 C addresses equipment markings, which can indicate the specific hazardous location class, division, and group for which the equipment is approved. Secondly, UL standards, such as UL 2225 for cable and cable glands used in hazardous locations, often serve as the basis for product certification. These standards detail the testing and performance requirements that equipment must meet to be deemed suitable for C1D2 environments. Thirdly, ISA standards, particularly ISA 12.12.1, provide guidance on the construction and testing of electrical equipment for use in Class I, Division 2 hazardous locations. Now, regarding the necessity of locking or set screws, the key considerations are the cable connector's design and its listing. If the connector is specifically listed and labeled for C1D2 applications and its design inherently provides a secure, vibration-resistant, and gas-tight connection, then an additional locking screw might not be strictly required. The listing ensures that the connector has been tested and certified to maintain its integrity under conditions expected in a C1D2 environment, which may include exposure to specific chemicals, temperature variations, and mechanical stresses. However, if the connector's design relies solely on the screw-type connection for its mechanical and electrical integrity without any additional locking mechanism, then a locking screw or other means of preventing loosening could be necessary to comply with C1D2 requirements. The rationale is that vibrations or thermal cycling can potentially loosen the screw connection over time, leading to increased resistance, sparking, or even complete disconnection, all of which pose ignition risks. The vendor who recommends the additional locking screw is likely taking a conservative approach, aiming to provide an extra layer of security against connection failure. This is a common practice, especially when dealing with safety-critical applications and hazardous locations. It's also possible that this vendor's connectors are not specifically listed for C1D2 applications without the locking screw, or that the interpretation of the relevant standards leads them to believe that the additional locking mechanism is necessary for compliance. Conversely, the vendor who states that the locking screw is not necessary likely has connectors that are specifically designed and listed for C1D2 use without the need for additional locking. These connectors typically incorporate features such as specialized sealing mechanisms, robust materials, and designs that inherently resist loosening under vibration. To resolve the discrepancy between the two vendors, firstly, carefully review the product specifications and certifications for each vendor's cable and connectors. Look for specific markings indicating compliance with C1D2 requirements, such as UL listings or ISA certifications. Secondly, request documentation from each vendor supporting their claims. This documentation should include test reports, certification certificates, and any other evidence demonstrating that the products meet the relevant standards for C1D2 applications. Thirdly, consult with a qualified electrical engineer or a certified hazardous locations professional who is familiar with the NEC, UL standards, and ISA standards. These experts can provide an independent assessment of the cable and connector designs and advise on whether the locking screw is necessary for your specific application and location. Fourthly, consider the specific environmental conditions at your installation site. If the area is subject to significant vibration, temperature fluctuations, or exposure to corrosive chemicals, it may be prudent to opt for the more robust solution with a locking screw, even if it's not strictly required by code. Fifthly, check with the authority having jurisdiction, OJ, which is the local regulatory body responsible for enforcing electrical codes and standards. The AHA may have specific interpretations or requirements regarding C1D2 installations in your area, and the guidance should be followed to ensure compliance. Sixthly, consider the long-term maintenance and reliability of the cable and connectors. A locking screw can provide an added measure of protection against connection failure over time, potentially reducing the need for frequent inspections and maintenance. Seventhly, examine the connector's installation instructions. The manufacturer's instructions will often specify whether a locking screw or other measures are required for C1D2 compliance. Eighthly, compare the overall cost and complexity of the two solutions. While the solution with the locking screw may be slightly more expensive or require more installation effort, the added safety and reliability may justify the additional investment. Ninthly, consider the risk assessment for your specific application. If the potential consequences of a connection failure are severe, it may be prudent to err on the side of caution and choose the solution with the locking screw. Tenthly, document your decision-making process. Keep a record of the product specifications, certifications, test reports, expert opinions, and any other information that supports your choice. This documentation can be valuable in demonstrating compliance to the AHA or other stakeholders. In summary, the necessity of a locking screw for multi-conductor cables with screw-type quick connects in C1D2 locations depends on several factors, including the connector's design, its listing, the specific environmental conditions, and the interpretation of the relevant standards by the AHA. By carefully evaluating these factors and consulting with qualified experts, you can make an informed decision that ensures a safe and compliant installation. Remember that safety should always be the top priority when dealing with hazardous locations.